I'm Brian Johnson, and I'm going to be joined with a good friend and colleague, Patrick Cooch. We both work in the Network and Edge group at Intel, and I work in the Intel Ethernet Products division. We just had name changes, so I have to remember how to say it. As a senior solution architect, and Patrick is a principal engineer in our network software validation team, I think. Sure. I'll let him explain that. So, where Naru talked about AI and hundreds or thousands or tens of thousands of systems, we're going to kind of take it a little bit different on what it takes to move the edge and the cloud, how to bring more sustainability as we move out to the edge with compute, and what does that mean? What are some of the things that we're doing within the Ethernet, at a network and edge group level, at an NEX level. This has been a big push and continues to grow. I got involved with it about a year ago, and really was eye-opening. And I'll try to share some of those things that I learned, and where I kind of had one of those aha moments of, wow, yeah, how do we handle that? And yeah, that would be a problem, kind of thing. So we'll go through that, and then we'll show some demos, so some pathfinding demos. And I want to kind of just lay it out there. These are things that we're looking at. So they're, I can't tell you, is that going to be in the next product? We don't know.
I'm checking the release notes.
Yeah. So just want to call that out. And also, as we get into this, I want to call out Manish Dave is one of our principal engineers that is working on this concept of elastic energy and proportionality, and I'm presenting a lot of his work. I just want to make sure we give him props for all the work that he's doing in this area. So when we start looking at how we scale from the edge out to, in the cloud investment, I mean, there's trillions of dollars over the next decade in investment going into this area. And there are a lot of climate-driven deployment challenges. And when I started thinking about this, it's like, yeah, we're talking about cell sites, we're talking about you're out in the middle of the weather. And then we start talking about, well, the weather in Oregon, where I'm from, is a lot different than Dubai and Alaska, and there are a lot of different things that you have to worry about. Also, where your power is coming from. How much are you relying on renewable versus solar and non-renewable types of energy? And so we started, this is one of these areas that I started thinking through. It's like, wow, there's a lot of stuff that we have to, that we could optimize, and using old data center type methods really they don't play well out there. And with the business mandates of zero net emissions, the focus on how to become more sustainable, really focus on sustainability. There's a lot of innovation that we can actually do, even going into more intelligent at a system level. I know some of the questions that came up in the previous, what are we doing, at a rack level? How do, things are getting hotter, faster. How do we deal with that? And so hopefully over, the next hour, we can talk through some of these different areas. So most of us know what carbon footprint, that's what our greenhouse gas based on our human interaction and whatnot. But when we start looking at the edge compute, what are those different challenges? And if we use the old methods of data center, here's your server, you're just going to run, that may not be the most efficient way of dealing with stuff out at the edge. And I'll go into that a little bit more. And then also, what about waste? You know, these things get beat up in the weather. What do you do with them? You're building in, you know, we have immersive cooling, you know, got all the different aspects of building these things up. You throw them away, but also, how do you take better advantage of it? You know, we used to waterfall servers down. Can't do that in some of these more proprietary form factors and stuff. So how are we dealing with that? And let's see, we talked about the energy. Oh, the environment. I mentioned that. You know, so those are some of the edge challenges. And most of us would think, you know, yeah, the weather, the energy, and all that. And so, how can we? You know, what are some of the strategies for optimization? And we'll focus on 3 in this talk around more effective or more energy effective hardware and software solutions. Discuss how to take advantage of the renewable energy at the edge and what does that mean? And how can that impact what we do at the edge? And then dynamic workload distribution to minimize energy consumption when we can, but also maximize the performance when we need it. So how do you adapt between those, those 2 sides? And in a data center, you just move more workload to that server, and we don't need as many servers on, so you power them off. But when you're out at the edge, those workloads may or may not be easy to move around. I mean, it just sits there and it's just burning cycles. So the concept of energy elastic systems, and this is, once again, this is what Manish is working on, and it's one of those terms makes sense. How do you expand and contract based off of your energy needs. And the key is around workload KPIs, the key performance indicators. And what does that mean? And understanding what will impact those KPIs, and how do you correlate those to business objectives and your SLAs and your service level objectives for that type of workload. And so we really look at how to optimize for the workload in the individual environments. How do you adapt to the different environments that you have? Sometimes you have solar energy, right? Sun's out. In Oregon, that's not very often, but
the Seattle pair.
yeah, you go back to Seattle, it's gray most of the time. Well, so solar, may not be the best renewable option because it's not available all the time. It only gets light 6 hours during the winter time. So how do you adapt to those type of things? How do you effectively use that energy that is available? That's one of and the optimizations. The rest of them are pretty self-explanatory. And then we look at the use cases. Yeah, we're looking at the data centers, but at the edge, how as we start moving stuff out, where does it make sense to keep consolidated? Where does it make sense to bring it out? Those are some of the topics that that we discuss a lot, because there's this the one size fits all type of solution really doesn't meet the needs of this type of environment. And so how do we create these? And these are the 3 areas that we'll talk about: the adaptive system and energy proportionality. And how do we deal with that? Energy time space shifting. Have you heard that term before?
No, but I'm just looking at the definition and I think it makes sense. Yeah.
Yeah, it was, first time I heard it, I'm like, one of my kids is in college for astrophysics, and that's the first thing, and I'm like, dark matter, what are we talking about here? And so it made complete sense once, and I got a little animation. We'll talk about how we can deal with that. And then at a systems approach, the big thing is, how do we, where do we get the telemetry? Where do we get the data to make decisions? And, especially around Ethernet, networking is very bursty. As much as, we've tried, well, okay, let's tweak this. Well, it's over by the time you figure out that you needed to do it. Something else is happening. And you're like, okay, well, how do we make that faster? And then you overcompensate. There's a lot of challenges. So how do we handle that at a larger system level as we start dealing with more of the edge type devices? Okay, so kind of going back, the key is around the workloads. What are the requirements of that workload? And, for a lot of things, more is better. If I can go faster, that's better. But, in one of the examples is looking at object recognition, you only need 5 frames per second. Any more than that, it's a waste. So how do you adjust to not just deliver more? Hey, I got better resolution. Who cares? That's just, you're just over processing, you're over delivering. So how do you keep as close to that KPI that allows the recognition to work, but not provide more data and move more data than is required? So how do you balance that out? And so that's why I went back to this KPI thing is, yeah, we're always trying to, okay, here's the minimum. But there's these bands now that we have to stay within in order to really look at optimizing for these type of different workloads, right? Because we've always said, okay, your request, response time, faster is better. Well, if you can handle the processing, throughput. If I don't need the data, why move it, right? Those type of things. And then looking at the business side of things, how do you scale it? How do you be, more cost efficient? And then we also look at the sustainability side of this. How do we make it, net zero is the, big push. And we need to build in that flexibility and how do you scale? And, the predictive planning is, what does next year look like? Last time I was here presenting at Network Field Day was 23. That was November of 19. Things in my world changed March of 20. That was the last time I did a actual face-to-face presentation. I was thinking as I was getting, walking through my slides, I was like, wow, I only can talk to one screen. I got to talk to people, not my monitor and all my other resources around me. I'm like, this is going to be weird. I'm really glad to be back, talking face-to-face. It is nice. But, a lot of things changed overnight for us. VPN, if you're in charge of VPN, you went from, I got a couple hundred people to my entire company is now having to log in. And that caused, that was one of the first things that we had to go figure out, how to get 85,000 people on a VPN when we didn't have that many connections available at the time. So go into this first area that we're pathfinding on is this is adaptive system and energy proportionality. So you think about rush hour traffic cameras. Lots of cars. You really want to have, as much processing is required to make sure you can handle understanding, do the object recognition and process that. And the analogy is, it needs to be a pretty high performance vehicle at that point. But rush hour, may be only on one side of the street. You don't need the cameras on the other side. It may be only on that street for in the morning, but not in the evenings, right? There are a lot of different characteristics in that. But then you have the rest of the day, just medium traffic, have to have a certain level of performance. An accident happens, you want to make sure that you have as much data as possible because you need to record that kind of stuff and be able to understand what happened, right? And what are the impacts. So you can't just look at, I only have 2 cars on the road because those 2 cars are stopped and there's a lot of other stuff going on. You need to capture more of that information. So you do need to be able to scale back up, even though it may be out of hours. And then when there's nobody on the road, 1 car every couple minutes, how do you deal with the power there? And how do you deal with the compute? There's a lot of different, there's a lot of processing for that high, at the top, but really not great methods of scaling back and, letting stuff just idle and not just waste energy, especially on some of the comms workloads. They run pull mode drivers. Those pull mode drivers just sit and spin. Doesn't matter. Patrick will go over some of those challenges as well. So then this time-space shifting. And this was one of those times that I had, I hadn't thought about this. This is, most of these stations have some kind of battery and they're solar powered. If you have low solar, it means you're running on battery or you're having to pull from non-renewable sources, right? What the concept of the time and space shift is, well, down at the bottom here, this renewable energy factor or ratio. There's a couple different ways that people call that, but I just called out the renewable factor. Is the closer to 0 you are, or closer to 1, the more renewable that energy is, right? So if it is highly renewable, maybe I can use more. If you are trying to keep it, if you have to use more non-renewable, then maybe you can cut back on some of the granularity of the information that you're processing. So the other method, and this is this time and space shift, is just move the processing to some, another station that has higher solar, direct, it's in the direct sun. Move the processing over there. So you have to have the network to be able to move the workload over to the stations that may have higher renewable energy ratios. So being able to move them, but also have the intelligence of, I know we're not going to end up with high traffic over there, right? So you have to pick places that we know, the game's not getting out, so you're going to have high density. So it's probably not the best place to go put, and offload that work. So
there's also that thing you mentioned earlier, though, like if I've got, say, some generic workloads that kind of don't really matter where they run, I'm going to go and run them in Norway because cooling's easy. I just open the window and
yeah.
maybe I got lots of hydro, so it's great. I can move that workload around quite easily. The problem with some of these sorts of workloads is you've got a limited geographical distance you can move.
Yes.
That's probably how do you solve for that problem?
It's like, and in some cases, I may be able to ship it off to Norway. I don't need, I don't need to review the video. It just gets processed and backed, and whatever, and then I don't care. But if you have to be able to adjust, traffic lights and, whatever other services, that we're dealing with here, or, emergency response, narrowing down, where that accident happened based off of these other areas and being able to divert traffic off and, adjust the on-ramp lights and all that stuff to try to, adjust all that, adjust all the signs around saying, hey, you've got to try, it's amazing. I sat there in one of these meetings and I was like, yeah, we have a ton of, Internet of Things, and all these different endpoints that all get impacted by these, by this edge computing. It was, I don't know, for me, it was one of those, I hadn't thought about it. I sat in data center thinking for way too long, I guess.
So being able to, this is Tim Bertino, being able to distribute edge workloads from a compute standpoint makes a lot of sense, right? Similar to drawing parallels to how we do it in the data center. But in these types of use cases, networking then becomes even more important. Do we need to physically change any of this architecture to be able to support that from a networking standpoint? And the reason I bring that up is you mentioned in some of these real-time use cases, low latency is very important. So does any of that, does network design have to change to be able to support distributed edge compute?
Yes, and that's part of the work that Manish is working on, and others within Intel, is understanding, we can't over provision, but under provisioning may actually be, more costly because you're wasting energy or you're not being able to process things as effectively as possible. And those are, those are things that, really, I don't know, as I said, for me, it was kind of an eye opener. A lot of light bulbs were going off, over spending the first 6 months. I was like, wow, yeah, how are we going to deal with that? Well, how about if we try this? It was actually kind of exciting after, just, okay, we moved from 100 meg to 1 gig, 10 gig, 40 back to 2500. And, the last time I remember this was around virtualization, when we said, hey, we got multiple servers, and now you have a switch inside your server, this software thing, and how are we going to deal with that? And we were all doing 1 gig, 8, 12 1 gig connections to a server. And, well, we got 10 gig. Well, we don't need it. 120 gigs. Yeah, we need 100 gigs now, but switch the virtual switches could only do a gig or two. That's all they could actually do. So adding a 10 gig, well, what are you going to do with the rest of the bandwidth? How are you going to break all that up? And that's really, I kind of see that as this time period as well, as we're looking at how do we grow the edge, how do we get all these different devices in, what else can we do, and how do we make it more effective? And as I was listening to Naru talk about the AI, and I brought up, well, it's HPC. It's HPC all over again. Oh, we're going to consolidate. And I'm like, yeah. Then we have this other thing that's trying to break all that back up, and how do we move it around? And it's some of this is going to take, we're going to be able to take advantage of AI. So this is a great time to be able to, start thinking about this, because how do we predict what's happening? How do we take all these, hundreds, thousands of parameters and predict, oh, we should move that over here? It's stuff we can't do. As I say, you sit there with a little lever. Oh, yeah, let's increase that. Nope, it's over. You missed it. And that was always really, that was really frustrating with virtualization. It's like, okay, how do we adjust for that? Well, we just had a live migration. How do we? And by the time you figured it out, it was over. And
yeah, like the DRS type stuff was good for a sustained burst, but Yeah, you get these short spikes.
Yeah, and it's like,
And
okay.
you end up pushing in this churn by moving things around when too late, and then you're causing more churn.
churn.
This
Yeah.
load balance. Yeah.
Yeah, live migration and all that stuff was great for servicing a server. You can move it over, and bring it down and fix something, do an upgrade, whatever, and you didn't have to, didn't break things. But now we just we just move the application. Why move the whole OS? I mean, that's containers have really changed. We've had to change the way we think about live migration, and just spin it up over there. Once they drain off, you move to a different method. And then, this all goes into the control. How do you observe this? Once again, we really have to look at the workload centric. What is that workload, and what is the requirement of that workload? And how do you balance those out across the different devices on the network in that area, maybe geographically, or the different types. Maybe one type needs more networking, more processing during one part of the day or a time period, and less so you can kind of swap where things are. How do we handle that? So the telemetry of those workloads, and that's I'll have Patrick here in a couple minutes talk about some of the areas when everything looks like it's running full blast. It's like, yep, everything's at 100%, but that may actually not be the reality of we're not actually doing anything with that 100% utilization. It's just empty poles. Build in the CO2 awareness, and this goes back to what your energy, renewable energy factor. How do you handle the different times? High traffic, you probably don't want to be generating more stuff. Less traffic, maybe, we can offset, and do things differently during different times with that kind of information, this renewable energy factor, and, the advanced decision placement, using AI. How can we take advantage of AI? How do we move, maybe little pieces of AI onto the server, onto the adapters that then can help predict, hey, I got congestion, I need more queues, I need less queues, I need, CPUs aren't doing much, okay, I can consolidate. There's a lot that we can do from the networking side, delivering packets up into a server or into a edge device. I still go back to my server roots. But and then how do you do this with something that's the federated side of things, where it's all being able to work across the different standards and stuff.